Good evening, class, and welcome to our performance management class for today. Our class for today will focus on the discounted cash flow. The last time we had this class, we talked about the non-discounting cash flow of appraisal of investment appraisal. We looked at payback period. We looked at accounting rate of return. These are the two main ones that we looked at. And we said the accounting rate of return is the average annual profit all over the average investment, or all over the investment at the beginning, or the investment at the end, depending on what the question wants you to do. Then we talked about the payback period, which is the shortest possible time to pay back all your investments, or to recoup all your investments from your net cash flow. These two that we did here last week did not take into cognizance the time value of money. And so today we are going to be looking at the ones that will take into cognizance the time value of money. We are going to be looking at something called discounting, the net present value method of investment appraisal, discounting annuities and perpetuities. Then we'll look at the internal rate of return. And that's basically most of the things we are going to cover in this chapter. So let's go right down here into the nitty-gritty of the matter. The time value of money. One of the basic principles of finance is that a sum of money today is worth more than the same sum in the future. For example, if you are offered a choice between receiving 10,000 naira today or receiving that exact 10,000 naira in 1 year time, which one will you choose? Let's assume that you want to use the 10,000 naira to buy dollars. It will be worth better for you to buy the dollars today with the 10,000 naira and put it in your dorm account than to receive the 10,000 naira in 1 year time and you get smaller dollar. So a sum today, if you invest, even if you invest this 10,000 naira today, you are expecting it to yield more money in the future because of the time value of money. Money appreciates with time. Sometimes money can depreciate too with time, as we can see in some naira dollar exchange. While the dollar is strengthening against the naira, increasing its value, the naira is weakening. And so this underscores the reason for applying the time value of money. The impact of time value can be estimated using one of two methods. One of two methods. The first one is called compounding. Now, compounding estimates future cash flow that will arise out of investment that is being done today. So it means that you are looking at putting your money in an investment today. How much will you be getting in the future? How much will it amount to in the maybe 10 years time? So that means that it is that money that is accumulating is said to be compounding. So it means that for compounding, you are looking for the future value of money. In compounding, you are looking at the future value of money that you have now. Discounting is another one. That's the opposite. In discounting, you are trying to look at those future money that you are expecting. How much are they worth now? How much is the future money? How much are they worth now? If someone now tells you that I'm going to give you $1,000 in 1 year time, how much is that $1,000 that 1 year time? How much will it be worth now? So you are bringing that money, that your future money, you are bringing them to today's terms. So it means that $1,000 in naira, then if you convert it to today's terms, it means it's going to worth more today, because $1,000, the value in naira that it is now, then in 1 year time, the naira value would have increased. So you see here that in compounding, you are looking at today's money. If I leave it, if I leave it till 1 year time, how much will it worth 1 year time or in the future? In discounting, you are saying that the money you want to give me in 1 year time, if you had given me now, how much will it have worth? So discounting is the opposite of compounding. And so when we are making an investment into the future, we are using compounding. When we are trying to appraise investments, when we are trying to appraise investments which will bring future cash flows, we will use discounting to bring those future cash flow to present terms. That is why you see discounted cash flow. Now let's go into more discussion with the discounting cash flow. Now, since we say that discounting is the opposite of compounding, the formula we have for discounting, which is this, we will have compounding to be the opposite. So this is a discount factor. I'll call it DCF. So this is your discount factor. Now, compounding will be compounding factor. It will be the reverse of this. It will be 1 plus r raised to power n. There will be no 1 over. So discounting factor is still the same thing as in maths. If you want to make this one, change it in its format, this discounting factor can be 1 plus r, then you say raised to power minus n. This is discounting factor, this is compounding factor. The difference is discounting has a minus, compounding does not have a minus. So in that way, you can really understand it. You can do it this way, no problem. Just know that this way you have it here, this way you have it here, is still the same thing here. They are all the same. So this 1 minus n is as the inverse. So that's what it means. So where R is in period interest rate, which is like the cost of capital, while N is the number of periods. So we'll be doing some little exercises and let's see a discount. Example, discounting. A person expects to receive 13,300 in 3 years. If the person faces an interest rate of 10%, what is the present value of this amount? The present value. So let's go back to our workbook here. This is the sheet we used for the last time. We want to continue using it for today's class. So I will come here. I will start it from here. This is discounted cash flow. It's a subtopic. Subtopic. Discounted cash flow. Wow. Discounted cash flow. All right, so we have our example one. So I was saying that discounted factor, discount factor, I'll say, which is called DCF, we say me using DCF, is 1 over 1 plus R raised to power n, which is the same thing as saying 1 plus R raised to power minus n, while compounding factor, compounding, I can call this on DF instead of DCF. Sometimes we see DCF, but let me call it DF. But DCF means discounted cash flow. Compounding factor will be CF. So it will be 1 plus R raised to power n. All right, that is our formula. Then we are giving an example here. Okay, so we are giving our formula here. It means that if we have a present value, which is PV, if you want to know your present value, it is your cash flow, which I'll call principal, plus okay, let me do it this way. It will be principal, open a bracket, 1 plus discounted cash flow, 1 plus discount factor. That's it. Then if you are having compounding factor, compounding is you want to know your future value. It will be your future cash, let's say your future amount multiplied by 1 plus compounding factor. Okay, all right, so let's look at it. You are asked to look for the present value where you are given, okay, let me say this is present value, this is amount. Let's call it amount. So we are given the amount here as 13,310. This amount is also called your future value. Okay, so if in PV, this A will be your future value. In FV, this one will be your present value. So your A, which is your future value, is 13,310. Now, your discount factor, of course, we know the formula. We are told that the number of years is how many years? is what's that? 3 years. That's 3 years. While your rate we are given as rate is 10%. 10%. And we are asked to look for the present value. And we said our present value is this future value, which is A, multiplied by 1 plus discount factor. All right? So that's what we'll be doing. Now, what is this discount factor? Let's go and find the discount factor. The discount factor alone is going to be 1 plus r raised to power minus n. Then your discount factor here is going to be 1 plus 0.1. I'll say 0.10 because this is 10%. So you just put 0%. If it is 5%, don't go and put 0.5. You put 0.05. Okay, so this is 10%, 0.10 raised to power minus 3. Now let's look at it now. Your discount factor will now be 1.10 raised to power minus 3. So let's see what is going to be. Our calculator here is going to be 1.10. You will now say, where's the raised to? Now, your raised to is this. In your calculator, you will see x raised to power y. So this x is the base. So the base is this 1.10, that's the base. This y up is the power. So it is saying here that when you have typed the base, just click on this, raised to power. Some calculators, you will see this symbol. It's called a caret sign. You will see this symbol is also power. So raised to power 3, then I'll just use this minus. I have to press 3 and use this minus. Don't go and say and put minus 3 by pressing this one. No, just press the 3 and put the minus. The minus will go with the 3 and it's going to give you 0.7. Always put it at least 4 decimal places. So 0.7513. 0.7513. So that's it. I beg your pardon. It's going to be not 1 plus discount factor. It's going to be, I've seen my error. It's going to be, I'll amend the formula. It's going to be future value multiplied by discount factor. So let's amend the formulas. That way, let's amend the formulas. Let me still put my FV here. Multiplied by discount factor. I'll also amend this. It is the discount factor that has the 1 plus. That is what made me to want to put 1 plus. So this is going to be amount, which is your present value, multiplied by compounding factor. So that's it. Okay, so what you will now do here is your present value will now be 13,310 multiplied by 0.7513. Now don't clean your calculator. Use every number in your calculator and just multiply it by 13310. Any answer you get, just look at it now. This is going to give you 10,000 naira. So it means that 13,000 naira, 310 in the future, giving a discount factor of 10%, will bring it to 10,000 naira today. To be 10,000 naira today. Now, in the same vein, even though we were not told, let's assume that you were given a present value of 10,000 naira and you have your compounding factor to be 10% and the rate or the number of years, okay, the compounding factor, no, not compounding factor, the compounding factor rate to be 10% and the number of years is 3 years. And you are asked to look for the future value. So you will say your future value is the same thing as your present value multiplied by the compounding factor. Now, not discounting. And so you will now say your compounding factor, this is going to be compounding factor. We know, okay, let's do it this way. Okay, so let's do it this way, which is still the same thing as your present value multiplied by, what is your compounding factor? 1 plus r raised to power n. Okay, which is the same thing as 10,000 multiplied by 1 plus 0.1 raised to power 3, which is the same thing as 10,000 multiplied by, and let's do this, okay, multiplied by 1.1 raised to power 3, which is still going to give us, now let's do it now. We'll take this 1.1, you will come here, raised to power 3, and there is no minus. That gives me 1.3313. Now, multiply it by 10,000. That gives me 13,310. So you see here, your future value is 13,310. So you see, it works both ways. If you have your compounding factor, it means you want to get future value of money, because in future you are compounding your money. If you are told discounting factor, so your compounding factor is also your discounting factor. That's it. Your compounding factor, the rate is the same, the number of years is the same, but it depends on the perspective. If you are asked to look for future value, then you use the compounding formula. If you are asked to check the present value, then you use the discounting formula. So that's it. All right. Okay, that is what was being done here. Illustration: discounting is the reverse of compounding. Okay, that's what is being done here. All right. Interpreting present values. The present value of a future cash flow is the amount that an investor would need to invest today to receive an amount in the future. So if you want to know, look at the question given to you. If they are asking you for present value, it means they will give you a future amount. You know it's discounted. If they are asking you for future value, they will give you an amount now. And so this is just what we did now. This example we solved in the reverse order is what is being explained here. Now, using present values. Discounting cash flow to their present value is a very important technique. It can be used to compare future cash flow expected at different points in time by discounting them back to their present value. Look at an example here. A borrower is due to pay a loan of 120,000 in 3 years. They say he is due to pay a loan of 120 in 3 years. Now the thing is this, when did he collect the loan? He collected it now, right? Or is no, what this question is saying is in 3 years time what he's going to pay is 120,000 naira in 3 years time. Now he has offered to pay extra 20,000 as long as he can repay after 5 years. The lender faces interest rate of 7%. Is the offer acceptable? Is the offer acceptable? Okay, so what it means is that he is going to pay 120,000 in 3 years versus 140,000 in 5 years. So let's work it out. So this is example 2. So we'll say this is example 2. Example 2, we say present value 1 is 100 and okay, no, sorry. Future value 1, future value 1 is 120,000, right? Then we have N1, which is 3 years. Then we have rates. The rate will be the same. Even if we put rate 1, we are having 7%, which is 0.07. Then we are asked to look for present value 1, which we don't know. Then we have future value 2. We are paying an extra 20,000, so it becomes 140,000. Your N2 happens to be 5 years, and your R2 is the same 7%, which is 0.07. You are asked to look for future value 2. Now we are asking which one will be acceptable for you. Now let's look at PV1 is the same thing as FV1 multiplied by discount factor. So your FV1 is 120 multiplied by 1 plus 0.07 raised to power minus 3. Now, this is the same thing as 120,000 times 1.07 raised to power minus 3. So let's see what it's going to be. Now we have, let's use this 120. Okay, let's not do the 120 now. The 120 will be last. 1.07 raised to power, you put 3 before you put this minus. Look where my cursor is this minus. not this, minus 3. So that will give you 0 point, put it in 4 figure, but use everything, 0.8163. So 0.8163. So this is like 120,000 multiplied by this. So you just simply multiply what you have here by 120,000. That gives you 97,956. 97,956. 97,956. So what they are telling you here is the 120,000 that you are supposed to pay in 3 years' time is just what in today's term as 97,560, 956 rather. So that it means is that if somebody were to invest, if he were to, if it means if he's investing 97,956 now, in 3 years' time he's going to get that 120. Or it means that the 120, which is the better interpretation, the 120 is going to be paying next 3 years is just what, 97,596. Now let's see the next one here. We have present value 2, which is FV2 multiplied by discount factor, which is 140,000 in the future, multiplied by 1 plus 0.07 raised to power minus 5. This is still going to be 140 times, this is still going to be 140 times, okay, 1.07 raised to power minus 5. So let's see what is going to be. I'll use a separate calculator for this now. 1.07 raised to power 5, and you put your minus. That will give you 0.712, 7130. 0.7130. Don't clean anything in your calculator. Just use the whole figure there in your calculator and multiply by 140 times 140,000. That will give you 99,818. 99,818. So it means the money you are going to pay in 5 years' time is what, 99,818. So which one will you rather want to do? I will rather want to pay in 5 years' time. So the client's offer is acceptable because the client is saying, let me pay you 140 in 5 years' time. And when you convert the value in 5 years' time to today, you are having, it is worth 99,000 in your hand today. That means it's just like saying, if you have the crystal ball to get that money that was supposed to pay you in 5 years' time, and they say, please give me now, give it to me now. It means instead of giving him 140,000, you are paying him 99,808. If he says the money you're supposed to pay me 120 in 3 years' time, give it to me now. It means what you would have given him is 97. So which one will be better for you to receive 99 or 97? It's 99. So it means the client's offer that, please, oh, instead of pay you in 3 years' time, let me pay you in 5 years' time and I'll add extra 20,000. and you look at the whole value, it is worth more in value than the first offer that was subsistent. So that's what we are saying. All right. Then we have here comparing cash flow. An investor wants to make a return. Okay, I'm still seeing some comments. Let's see. Someone is saying, sorry, sir. What are we sorrying for now? Talk to me. Can you explain why I choose 99,000? So I'm asking you, if somebody wants to give you 99,000 now or 97,000 now, which one will you choose? I'll choose the one that have a higher present value. ₦120,000 paid in 3 years. Today's value is 97. Of course, he's not going to tell me that he wants to give me 140 in 5 years' time, because in 5 years' time the value would have dropped. He now said, instead of me collecting 120 in 3 years' time, let me add 20,000 and give you 140 in 5 years' time. I now converted the 140 to today, and I'm getting 99. So if I'm asked between giving me 97K today or 99K today, which one will I take? I'll give you 99K. I will collect 99K. That's what it means. And so, if you have to collect 99K, it means you are accepting the offer of paying me 140 in 5 years' time. I guess that clears the question. As we keep solving, you will be seeing certain things that will make you understand. An investor wants to make a return on his investment of at least 7%. He has been offered a chance, he has been offered a chance to invest in a bond that will cost him 200,000 and will pay 270,000 at the end of 4 years. In order to earn 270,000 after 4 years, an interest of 7%, the amount of his investment will be. Okay, so now let's see what he's saying now. Let's see what example 3 is saying. So this is example 3. Example 3. Now let's look at it. He wants to make an investment of at least 7% per year. So now we are saying rate is 7%, which is 0.07. He has been offered a chance to invest in a bond that will cost 200,000 and will pay 270 at the end of 4 years. So option one, bond, present value 200,000, future value 270,000, 270,000. Now, he wants to look at it whether investing in this bond of 200,000 now to get 270 in future, which is how many years? After 4 years. Okay, at the end of 4 years. So N is 4 years. He wants to see whether this is a better deal. Okay, so what we will now do is we are going to ignore this present value, right? Now let's look at it now. The man wants to know, if I were to invest in anything that will give me 270 in the future, how much should I invest in now to get 270? Now the thing is, if his present value is smaller than 200,000, then he should not invest in the bond. Because why will I pay 200,000 to get 270 when I can invest less than 200,000 and get 270? Now, if the investment turns out that you will need to pay more than 200,000 now to get 270 in the future, then he will not invest. He will rather invest in the bond. So it means option two, investment, you don't know. So let's see what the future value of investment, how much is it supposed to invest now. So let me call this one PV1. Let's call this one PV2. Okay, so we'll say PV2 will be FV multiplied by DF. So your FV is 270,000. Your DF will be 1.07 raised to power minus 4. Just want to keep it straight because this is 0.07. Then you are going to add 1 plus. So we have done it straight since we've seen the principle there. So now let's look at it now. 1.07 raised to power minus 4. That will give me this whole thing here. I'll just multiply it by 270,000. I'll take the nearest whole number, 205,982. 205,982. So it means that ordinarily, if he wants to make an investment, that should give him 270,000 at the end of 4 years, he needs to invest 205,982 now. But now they are telling him, look, don't go and do that investment. Just bring it and bring just only 200,000 and buy a bond. And in the end of 4 years, we will give you that 270. Which will you do? Of course, you are going to invest in the bond because you'll be spending less now than doing your normal investment. Now, if you notice, this is different from a client wants to pay you now. Or is the first example we did when the client said, okay, let me pay you an amount in the future. You converted it to now, and you want to see which one of them is higher and accept. This one is you are the one accepting money. You are the one accepting payment. So you rather want to accept the one that will pay you higher today. But if you are the one spending or investing, you rather want to invest the one that you will spend lower now and get the same returns. So that's what this is all about. So okay, 20610. Maybe they converted this is to some decimal fraction. We use everything in our calculator. So it means that he needs to invest 200,000 in the bond. So that means the bond will provide a returns in excess of 70% per year. So it means if you invest in the bond, is using smaller money and is making more. Now, how much would an investor need to invest now to have 100,000 naira after 12 months if the compound interest on the investment is 0.5? Now we want to know how much we are going to invest now to have a future amount of 100,000. Is the same discounting factor. Even if they call it a compound interest, okay, now they set off, this is per month, okay. So it means that if the compound interest of the investment is 0.5% each month, okay. So what it means here is we are going to make it like this. Now let's look at it this way. Example 4. Example 4, we'll say present value we don't know, future value, how much is it? 100,000, 100,000, okay, after 12 months. So we can say N will be 1 year. Then we'll now say M will be in months, 12 months, 12 months, okay. So how would that be? So we are looking at the interest rate. R is 0.05 because we are told is 12%, 0.5%, sorry, 0.5%. So what I wanted to write, 0.5%, 0.5%. So now our formula will change because when we are using months, we need to do something, okay. We will say our present value is the same thing as our future value multiplied by, of course, discount factor. Now we will now say future value multiplied by 1 plus R raised to power M times N. So it means your future value is 100,000. 1 plus 0 point, now this is 0.5. 0.5 divided by 100. If you are in doubt, you just do it. 0.5 divided by 100 is 0. There are two zeros after the point. 1, 2 after the point. Then M is 12 times 1. N is 1. So this is 100,000. 1.005 raised to power 12. So you will start 1.005 raised to power, to be minus 12, raised to power, put your 12 and you put your minus. That gives me everything here multiplied by 100,000. That will give me 94,191. 94,191. So that's it. So it means that, okay, they say it's 190, one is 191. It means you must invest 94,000 naira now. All right, so now this leads us to discount tables. This leads us to discount tables. So discount factors can be calculated as shown earlier, but we can also obtain it from discount tables. So discount tables have been done in order to use discount factors. So now how do you read this table? You'll see a discount table given to you by your examination. Your examination question paper will have discount table. So you will need to know how to use it. Let me see if I can get a discount table. Um, let's see one of the questions we are about to solve today. If we can use discount table on it. Let me see. So that we'll just open that and let's see. Profit statement, cash flow statement. No. May 16. May 16, question 1. So let's just open this May 2016 and use the discount. So May 2016, let's just open it down there and see what is being given to us. So this is May 2016. Go to the ending of the question. You have been given formula, 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 and this is the discount table that you are given. This is the discount table. So this is from 1 here to 10%. It now continued under 11 to 20%. All right. So these are the tables you are given. So this is the table we are talking about. So what it means here is this is 1%. If we are discounting it for 1 year, this is 2% for 1 year, 3% 1 year. So this is 1%. If it is 2 years, what will it be? So now let's see here 5%. Let's see 5, 6, and 7. Let's see what is here. 5, 6, 7 is the same thing that we have here. So how did they get this? For 5%, let's just do it now. Let's just do 1 to test. So it means that 5%, which is 0.05. So it's going to be 1.05, all right, raised to power minus 1. Let's see what will give us. 1 1.05 raised to power minus 1 gives you in 4 decimal place, it gives you 3 decimal place, it gives you this, right? Now, if we were to make it 1.05 raised to power minus 2, gives you the down one, second one. So you can on your own do this, or you can decide to go to the discount factor table and take it. I will give you in 3 decimal places, fine. So you can go and take it, or if you don't want to use theirs, you use your formula. So we'll be interchanging and be using theirs and also using formula. So Let's go straight now to what we are going to do. Net present value. Net present value. What does it mean? Introduction to discounted cash flow. So you'll be seeing DCF means discounted cash flow, meaning you will need your discount factor. Discounted cash flow is a technique for evaluating proposed investments to determine whether they are financially worthwhile. Now, there are two methods we can use that will require discounted cash flow. The first one is the net present value method. Now, look at it now. Net present value. When we are doing discounted cash flow, we are saying PV, present value. Now, for you to say net present value, it means for you to have a net, it means you must subtract something. So it means that what you are investing now, what you are investing now, you have a series of cash flow every year. The cash flow you receive in year one, cash flow you receive in year two, unlike the one that you want a lump sum at the end of 4 years. But this time around, every year you keep getting. You get one in year one, you get one in year two, you get one in year three, you get one in year four. All the 4 years cash flows are added together, and you are deducting what you have invested today. That means you have a net. What you have invested today is you invested it in the present. So it is already in present value. The money you are going to get in year one, you will need to use a discount factor for year one to bring it to year zero, which is present. The money you are going to get in year two, you will need a discount factor for the second year to convert it from year two's value to year zero, which is present. The same thing for year three, the same thing for year four. You add all the cash flows that has been converted for year zero's term, and you minus what you invested today, which is already in present tense. Then you have a net. So that is it. Then we have the internal rate of return. This is different from accounting rate of return. Now, this is the actual return. Is cost of capital. What is the cost of capital that you are investing into the business? Okay. All cash flows are assumed to arise at a distinct point in time. They said all cash flows are expected to arise in a distinct point in time. Now it means that it's usually at the end of the year. So it means that this is one of this is one of the disadvantage. So somebody that gives you money of 100,000 in January 1, at the end of January, in December 31st, that is when the compounding is taking place. If I have decided to put the money in November, it's still going to be the same discounting. Let's not talk about that much. The discounting is done at the end of the year. For example, 20 million in 4 years are discounted as if they arose at a single number or amount at the end of year four. All right, so now let's look at the steps in calculating NPV. Step one, List all the cash flow expected to arise in the project. The first one is the initial investment, which is an outflow from you. You will normally put it in bracket because it's an outflow. Then all the future money you are going to be getting, which are inflows, you put them in positive. If there's going to be any outflow in the future, put it in negative. Then you discount all these cash flows to their present value using the cost of capital discounted rates. So it means you have discounted them to today. The net present value is the difference between all the present value of the costs and the benefits. So the project is going to be acceptable if it is positive, just the way we did ROI when we are doing this return on investment and residual income. So NPV is having that similar approach of return residual income. If it is positive, accept it. If it is negative, it means the returns is lower than the cost of that you have on the project. Now let's look at an example. Let's look at an example. A company with a cost of capital, what's the example number? Example 5. This is example 5. So this is example 5. Example 5. Now, a company with a cost of capital of 10% is investing in a project with the following cash flow. So year 0, so let's start. Year, we have 0, 1, and 2. So year 0 is now. Year 0 is now. Then this is the cash flow. So that's the cash flow. 10,000, 6,000, 8,000. This is 10,000, 6,000, and 8,000. Normally, you don't, if you are doing non-discounted cash flow, you will say 8 plus 6 is 14. 14 minus 10 is 4,000. Your net cash flow, you will say is 4,000. That is for non-discounting. Now you now say your discount factor. What is your discount factor? 10%. Your discount factor, 10%. So what you will now do here is we use our calculator and we can use our table. We can say for 10%, which is 1.01, no, 1.1, 1.10 or 1.1 raised to power 1 minus 1, and I will have 0.909. So I will say for year 1, 0.909 is for year 1. For year 2, I will have 1.1 times raised to power 2, that's minus 2. This is 0.864. 0.864. And this is discounted cash flow. Now we'll come back to this number 1. Now let's see this one here. This is for year 1. If I multiply it by how much do I have for year 1 here? 6,000. Let's say I multiply this by 6,000 and I'm getting 5,455. 5,455. Let's be sure we got the right thing. 5,455 because of the decimal. Then I do the second one here and I multiply, sorry, 0.826, not 864, 826, 826. Now, if I were to multiply this by 8,000, this will give me 6,612. 6,612. Let's be sure. 6,612. Now let's look at the first one here. It is already in present tense. It is already in present tense. So what will be the discount factor here? Now, anytime we have year zero, this is always a discount factor. Let's do it. 1.1 raised to power 0. And in maths, anything raised to power 0 is 1. So your answer will be 1. So there will be no need for you to go and do 1. And you will never see any discount factor starting from 0, because anything, you don't see any discount factor having year 0. And you never see discount factor as 0. But you could see 0 point anything. But ordinary 0, no. Period ordinary 0, no. Because for period to be 0, is already in today's term. Any amount you see now is now. It's already in today's term. So anything raised to power 0 is 1. So it means that 1 times minus 10 will give us minus 10. So this is your discounted cash flow, which is like your present value. I'll call it your present value. Maybe that's a better word here. This is your present value, because normally your future cash flow multiplied by your discounted factor, this is your cash flow. I'll call it future value multiplied by your discounted factor, which we know will give you your present value. So this multiplied by this will give us this multiplied by this. Now, let's see. We have 10,000 in the negative plus 5,455 plus 6,612. Now that's going to give me 2,067. 2,067. So this is your net present value. Now, if you are not using discount factor, you would have been saying 4,000. This is because you didn't use discount factor, and which is wrong, because time has affected it and it's now 2,067. So now, will you accept this project? Yes, because this is a positive figure. It's a positive figure, so you need to accept that project. All right. Let's see what they wrote here about. Note that the above example refers to year 0 as year 1 and so on. Okay, refers to year 0, year 1 and so on. This actually refers to points in time. Year 0 is now. Year 1 is the end of the first year. Year 2 is the end of the second year. Sometimes you can see T0, T1, T2 and all that. It is less confusing to think of the project starting at time 0, rather than describing it as year 0. as there is no year zero. So, but we can still forgive ourselves and call it year zero, but we can call it times zero. That's what this place is saying. Now look at a practice question. A company is considering investing in a new item of plant costing 53,000 to make a new product. The product will have a 4-year life, and the estimated cash flow over the 4 years are as follows. Look at them. And um, we have the discount factor rate as 11%. We'll just do the first one. This is just to practice. So practice question one. We just do only practice question one. We will not do that of two. That of two is your assignment. So this is practice question one. What are we asked to find? The NPV. Discount rate is 11. So I will come here. This is year. And we'll say this is 0. How many years we have? Take up to 4 years. So we have 1, 2, 3, and 4. And this is our cash flow, which is our future value. We have our discounting factor. Then we have our PV. So that's how we're going to do it. Discounting factor is 11%. So what's our cash flow? The cash flow costing 53,000. So 53 is spending on year 0. So what are the cash flow? 17, 25, 16, 12. 17, 25, 16, and 12. So let's see. 17, 25, 16, 12. So now instead of, so we'll go to 11%. This time around we are using tables. We don't want to be calculating. We are using tables. 11%. 0.901, 0.901, 1 point, 1 point, yes, 1.713, 1.713. Then here, get it. Okay. Then the third one should be 2.444, 2.444, and the next one should be 3.102. That's third year. 3, this, ouch, I've made a mistake. So let me amend them. This is 2.444. Let me do the last one. I'll come back. The fourth one is 3.102. 3.102. So I'll be cleaning. This one here will be 1.713. Clean off this. This should be 0.901. And I'll clean off this. This should be 1. Now let's just test this discount factors if it's so. We have 1.1 raised to power. Let me test this for raised to power minus 4. Let me test the last one. So you see this table here, stable here stable here. Let me see what was given to us here. Because I was not supposed to be seeing 1 point in anything. So this is annuity table. Oh, this is annuity table. Annuity table is different from discounting table. You are given a discount table. You are supposed to use an annuity table. This is a annuity table. I know why. So the only thing that will be correct in annuity table with discount table is the first one. So let's use our calculator and do our discount table. So the first one, 1.1 is always correct. So let's not do the first one. Do the second one, raised to power 2 minus 2, 0.0, oh, no. 1.11, not 1.1. Is a problem. 1.11. This one is 11%. All right. Raised to power 2 minus 2. This will give me 0.882. 0.882. 0.882. Let's still do the number one just to be sure. 1.11 raised to power 1. 0.901, yes. 1.11 raised to power 3 minus 3. This will give me 0.731. 0.731. 0.731. 0.731. In number 4, we have 1.11 raised to power 4. 0.659. 0.659. 0.659. I would advise you use your calculator. So one of the mistakes I made was I was supposed to be multiplying them straight. So but now I will not use, in case you didn't multiply them straight, you use them accordingly. So let's say 17,000 multiplied by what we have here, 0.901. That will give you 15,310. This will give me 15,310. This is already 53,000. So we'll do the next one. Oh, 317. What was I even thinking? 15,317. The next one will be 25,000 multiplied by 0.882, 22,050. 22,050. We do the next one. 16,000 multiplied by 0.731. That will give you 11,696. And the last one, you have 12,000 multiplied by 0.659. You have 7,908. So you see, as the years increase, the discount factor reduces. So now your net present value will be this final value here. So I have the last one in my calculator. Let me just add up, plus 11,696 plus 22,050 plus 15,317 minus 53,000. You have 3,971. 3,971. Say accept. This is positive NPV. So that's it. Now we won't be doing the example study practice question 2. That's for you. So there are two methods of doing the discount factor as shown below. There are two methods of presenting discount factor calculation. Format 1, we have year 0. We have two items. Okay. Okay. We have machine. You want to invest in a machine. You have 40,000. Discount factor is 0. 10%. Of course, it's going to be 1. Stay 40,000. You invest in working capitals. You invest in working capital. When you invest in working capital, you have 50,000 as what you want to invest. It's still 0. Now your cash profits or your cash flow is 20,000 from year 1 to year 3. If you add all of them, that's another method. If you add all of them and you multiply by, okay, so look at what they are saying here. If you use this kind of thing here in this example, you come here and you say, let's try if we get the same thing. We have 17,000 plus 25,000 plus 16,000 plus 12,000. This is 70,000. Okay, so what they are saying now, let's see what they are saying. So we can now say 4. If we just say 70,000 multiplied by 0.659. Okay, no, that's not what they are saying. Okay, I get what they are saying now. All of these, you add them together, 70,000. You add all of these together, 0.901 plus 0.882 plus 0.731 plus 0.659. This is your discount factor. 11. Let's see something here. 11 for 4 years, 3102. It cannot be the same. Let's just look at our own here. So this is what we have as our discount factor. When you add them up, if you multiply them by 70,000, okay, it's not going to achieve the same thing. So I'm trying to understand what they are saying here. Cash profit 120,000, discount factor, sale of machine at the end of year 3, you need to do the discount factor, recovery of working capital, you are going to do the discount factor. So this is one presentation. Then format 2, I think this is what I prefer. Year 0, 1, 2, 3. It's the same thing we did year 0, 1, 2, 3 here, but since we're having a lot of things down here, so we put the years like this across. In year 1, you made an investment of 40,000. You have a working capital of 50,000, 5,000. Now look at your cash receipt. Okay, now this is annuity. I get it. Annuity. So this is 50,000, 50,000, 50,000. Okay, they now use annuity formula before. This is your cash flow. Look at your cash expenditure. 30, 30, 30. It boils down to 20 in the 3 years. But in the case here, at the end of year 3, look at what you bought the machine, 40,000. And the scrap value of the machine is 6,000. Because I think you are selling the machine off for sale of machine 6,000. So when you sell the machine 6,000, money is coming in. Your working capital invested, you are recovering it back, money is coming in. Okay, so that's why we have this is 6 plus 5, 11. If you add 11 to 20, it becomes 31 here. So discount factor at their different rates. So this is your net cash flow multiplied by that. So this is the format 2 that I probably um, like to do. And they say it's easier because the discounting factor for each year will only need to be done once. All right. Now, profitability index. Profitability index. Profitability index can be used to compare investments. The profitability index is the ratio of the NPV to the capital invested. So it means that what is the NPV? So profitability index, which is PI is equal to NPV, okay, PI equals to NPV all over capital invested. So in the last example, we have this is our NPV and our capital invested, we spent 40,000. So when we divide, we are getting 32.45%. That is your profitability index on the investment. Then we now talk about annuities. Annuities, discounting annuities and perpetuities. Now, annuities are you are getting equal amount of money for every year for a number of years. Annuity is a constant cash flow for a given period of time. It's just like saying that somebody is giving you a cash flow, you invest in an Uber You invest in a car which you want to use for Uber, and you are paying a particular amount of money every month. That's annuity. Or you are paying a particular amount of money every year. Or you want to buy a house and they tell you you pay a large sum of money now and you'll be paying a particular constant amount every year. That money you are paying is annuity, as long as they are equal amount of money every year. The net present value of annuity, the net present value of an annuity can be computed by multiplying each individual amount by the individual discount factor and then adding each product. So what they are saying here is the discount factor for year one, discount factor for year two, and discount factor for year three. If you add them together, it will give you the annuity for year three. What do you mean by annuity? Now let's explain what is here, because it's an annuity. It means here that for year two, you have added year one and year two to get annuity for this line number two. For year six, you have added for year one, for year two, discount factor of year one, discount factor of year two, that's up to year six, and you now add them and you put the one figure here. So it means you would have done discount factors along normally. So you see why the annuity rate is being given to you. But you can use a formula to get your annuity rate. Now look at the formula method for annuity rate. Annuity is 1 over, okay, so this is the formula here, 1 over R multiplied by 1 minus. Anyway, I like this second formula more because you see some elements of how we do discount factor here. So, but instead of you to remember that formula, you just come here to take the discount factor. So they're even giving you the formula here. They have even given you the formula 1 minus 1 plus r raised to power minus n all over r. So it's the same thing here. So method 2 is used frequently. So you can either come to the table and see the formula and use it, or you pick the table. I will suggest you pick the table formula. So let's do this. We can do it in two ways. We can do it in two ways, or let's say in three ways. Now we are saying this is example 5. Is that example 5? Let's see. Oh, that would be example 6. Example 6. I'll call it annuity. Annuity. So now we can decide to do it this way. Cash flow 1 to 3. So let's see 50,000. So we can say method 1. This is year. There is no zero. Just say 1, 2, 3. I have cash flow 50,000, 50,000, and 50,000. Then we have our discount factor. How much is that? discount factor. We are not told what the discount factor is, but let's see workings. Okay, it's 9%. Let's see 9%. 9%. 9%. So I'll come here and I'll say 9% is as good as saying 1.09 raised to power 1. So that will give me 0.917. 0.917. Let me call this on our present value. Just multiply this by 50,000 straight. Multiply by 50,000 gives me 45,872. 45,872. I'll come down again. 1.09 raised to power 2 minus 2 is 0.842. 0.842. I will just need to multiply this by 50,000. That will give me 42,084. 42,084. Then the third one will be 1.09 raised to power minus 3. That will give me 0.772. 0.772. I'll just multiply it by 50,000. I have 38,609. 38,609. So I will just add this. So I have 45,872 plus 42,084 plus 38,609. That's going to give me 126,565. 126,565. This is one method. Now, because they are all of equal amount, I can just say year 1 to 3, cash flow, annuity. I have 50,000. Now, my annuity factor 9%. Now, I can come here and do it this way. I'll just add everything here. Let me use another calculator. I have 0.917 plus 0.842 plus 0.772. I have 2.531. 2.531. If I go here, number 9, I have under 3, 2.531. That's how they got that 2.531. They would have done discount factor year 1, year 2, year 3, and they add them together. That is what I was saying. Now, you just go to the table and get them instead of doing them one by one like this. So that's what I wanted to prove down here. Then you come here. This is going to be your present value. So this is now your net present value. So this is still your net present value because it's just one figure. So you have this here already in your calculator. Just multiply it by 50,000. And that gives you 126,550. But because of rounding error, I'll use it as 126,565. And that's the same thing. All because of rounding error. the decimal places, you round them off. So that's it. So you will do your practice questions by yourself. Now, perpetuity is a constant annual cash flow forever into a long-term future. So now, in annuity, you have a fixed number of years that you are going to do it. And if you have 10 years annuity, you just go to your annuity table and look at the percentage and take it, trace it down to the number of years. But for perpetuity, is forever or very long. You just use 1/r. That's your perpetuity factor. 1/r. So it means that if you are paying a cash flow 2,000 naira in perpetuity and your cost of capital is 8,000, is 8%. So you need to say 1/your r, 1/8%, multiplied by your annual cash flow. It means that your discount factor is 25%, 25,000 naira. That is your present value is 25,000. If you are paying 2,000 naira forever for 8%. So we'll go straight now to, these are some of the application of NPV and discount factor. Use it in finance a lot. Use it in loan repayment. You want to calculate, do things in finance. You want to save, buy house, sinking fund. It's another thing. So we'll just go now to internal rate of return. Now, what is internal rate of return? The internal rate of return is another method of investment appraisal that uses the discount factor. Now, the internal rate of return is the discounted rate of return on the investment. It is the average annual return from a project discounted at RORR. The NPV of the cash project must be 0. So it means that IRR is the discount rate R that must give you an NPV of 0. So I usually call it that IRR is the rate at which you break even in your NPV. What I mean is that your NPV is neither positive or negative, it is 0. And it's good to know that, so that you will know that what is the cost of capital that you are supposed to be paying. Let's say, for example, you have a cost of capital, you have a particular cost of capital, and you are doing your investment, and you normally say if your NPV is positive, it means your if your NPV is positive, it means you are spending more, you are getting more returns than what you spent. But sometimes you want to look at what is the lowest cost of capital in this your project, such that anything lower than that, you will not make any returns. That means you need to look for your NPV. The company might establish a minimum rate of returns that it wants to earn on an investment. If other factors such as non-financial consideration and risk are ignored, if the IRR of the project is equal or higher than the minimum, then the project should be undertaken. It means that if the IRR is higher, let's say you have a cost of capital of 10%, and your IRR is higher than that, it means you should accept it, because at that point your NPV is zero. At that point your NPV is zero. Okay, so you should accept. If the IRR is lower than the required minimum, then it should be rejected. So it means that since NPV and IRR are discounted factors, they should be giving you the same decision. Unlike return on investment, and that's ROI and ROI, that sometimes conflict, IRR and NPV will not conflict. And the thing of the matter is, if you want to calculate IRR, you must do NPV. Now, to calculate or estimate IRR, you should begin by calculating the NPV of the project at two different rates. One of the NPVs should give us a positive NPV, and the other one should become a negative. But it's not compulsory that it must become negative. They could be two positive, they could be two negative. All right. Then, but for better accuracy, one should be positive, one should be negative. Then you will now need to use the interpolation formula. And this is the interpolation formula. IRR equals to A percentage plus NPVA all over NPVA minus NPVB times B minus A percentage. Now, NPVA, this A percent is the the percentage where the NPV is positive. The B percent should be the NPV, the percentage where NPV is negative. Now, the thing you should know is, if you want to achieve a negative NPV, your rate should be higher. If you want to achieve a positive NPV, your rate should be lower. So normally B will always be bigger than A. All right, so let's look at one example, and that will be a wrap. A businessman requires a minimum returns for his cash flow 12%. Okay. A proposed capital investment has the following expected cash flow. Now look at year 1 to 4. Look at year 1 to 4. Now look at the cash flow non-discounted. Now look at discount factor at 10%. Now you know how we calculate discount factor at 10% now, right? So this is year 0. At year 1, this is the discount factor. At year 2, at year 3, at year 4. Now look at the present value. You multiply your cash flow by your discount factor, you get your cash present value. The same thing you do for year 2, year 3, and year 4. Now you add them up. When you add them up, you have positive NPV of 2,2057. Now, I said you want a negative NPV. Your negative NPV, for you to achieve it, your percentage must be very high. Now, let's look at 15%. So this is still your cash flow. At year 0 is 1. And when you multiply, it gives you 80,000. At year 2, 15% gives you 0.870. Multiply by 20,000 gives you this, 17,400. At year 3, 15%, the discount factor will give you 0.756. When you multiply by 36, it gives you this 27,216. That is how you do for all of them. And now when you add your present values, you are having minus 5,920. Then you will now quote your interpolation formula. This is your interpolation formula. Your A is the percentage that gives you a positive NPV. What percentage was that? It was 10%. Now your NPVA, what is that NPV that gave you positive? Is this 2,057. Then over NPVA is still the same thing. Minus, now this minus here is the same thing as this minus. Now NPVB is this 5,920. This is a bracket, is a negative. That's why you're seeing minus again. That's why you're seeing minus again. So minus minus, that's what it means, minus minus. And so this will now change to plus, as you can see here. Now B percentage is 15%. I said it's going to always be bigger than A. A percent is 10. So when you minus 15 from 10 is 5. So you tidy them up here. This numerator remain the same. You have added these two. It gives you 7,977. This remains 10. This remains 5. Now in your board mass, you do the bracket first. Then you do your multiplication. So 2,057 divided by 7,907 will give me this figure here. Then you multiply it by 5%. So it's going to give you 10% will still remain, which is still the same thing here. So this multiplied by 5% will give you 1.3%. When you add this to 10%, it gives you 11.3%. So it means that 11.3% is the accounting rate of return. It is lower than the expected returns of 12%. It means that this is the NPV value, this is the rate that your NPV will be 0. But here, this is your expected return, and you are, or this is like your cost of capital, your expected cost of capital that should supposed to give you NPV 0, and you are now getting this. So it means you take the higher one. You reject this project because this is less than the target return. This is the this is the return you are supposed to get from this project. This is what the company is targeting. So you don't meet up, you reject. If it was higher, you accept. So we have come to the end of this discounted cash flow. You can read up the other ones here because of time. You can read up the other ones here. You can read them up for lack of time. So, but the basic is what we've just done now. We've done the NPV, and we've done the IRR. So the question we are going to be seeing here will be telling you NPV, IRR. Is this okay? That's the PM. Let's just glance at the question. If it is something that can be solved, it's fine. Otherwise, we'll move it to the next class. So this is the question here. It's not something that can be solved today. So we'll move this question to the next class. This is what we'll use in opening our class. Then we will move to the topic for the next class. So, thank you so much for coming to class. It has been an eventful one. We hope to see you again in the next class where we'll be starting on time and not behind time. Thank you so much, and I'll see you in the next class.